Hi, we are 26562 MechTech, an FTC team, and in this video we will be showing you how to use the sketch tools in Onshape. This is the first part of our three-part video series. Without further ado, let's get started. First, you're going to want to select a sketch plane. So, our first tool would be the line. There's two types of lines. One is just the regular line. You select a starting point and then you extend your line to wherever you want, and the second point will be there. In order to define this line, you can use the dimension tool to define its length. Let's let it be 80 millimeters, and you have to define in this case you would have to define the angle too. Like you could say the angle from the line of the back plane to the line would be 40 degrees. Now, if you've noticed that a sketch will be blue when it is undefined and black when it is fully defined. Alright, let's move on to our next tool. The next one is the midpoint line. The midpoint line is similar to the regular line, except for you select a midpoint and basically instead of your second point being the other endpoint, it would be one of the endpoints, and the first point you selected would be the midpoint. In this case, we also have to define it by selecting the length and the angle of the line to, let's just say, a plane. Oops. As you can see, it's fully defined. Alright, moving on. Next up, we have the rectangle. Our first type of rectangle is the corner rectangle. How the corner rectangle works is you select one point, which would be your corner, and you can extend it in two dimensions, the height and the width. Both of those which need to be defined. So, in this case, I will show you how to define it if one of the points is not the origin. So yeah, once again, we have our height and our width. So let's just say that's 40, and we can say that that is 60. So we need to define this rectangle, left and right, and up and down. So first we can do up and down. The height of this rectangle would be, let's just say 20 millimeters from the origin, and it would be, let's just say 20 millimeters again from the origin in two different directions. This defines our sketch. Moving on to the next type of rectangle, which is the center point rectangle. The center point rectangle is similar to a circle, where you select a center and you have the height measurement and the width measurement. I will show you a scenario where the center is not the origin. So, like showed in the other rectangle, you need to define the length and the height. The length and the width. And you must define the center point. So we can define it to the origin, like, let's just say 40 millimeters across and 30 millimeters up and down. Alright, so the next rectangle will be the aligned rectangle. Basically, you would pick 2 points. It's like a line. Like, first you'd start off with making a line, and your rectangle would be would just go extend out of that line. So once again, we're going to want to define our length and our width. As you can see in this scenario, the line does not have to be vertical or horizontal, or the rectangle is not straight. So we can fix that if needed. You can fix that by making the distance from the bottom to the back plane. You can make that angle 0. That would make it straight and aligned to the back plane. Next, we want to know how far the rectangle would be from the origin left and right. So what you can do is you can use your dimension tool again and define that. Now we have a fully defined sketch. Our next tool is going to be the circle. Our first type of circle is the center point circle. How the center point circle works is you select any point on the sketch, and that will be your center. You can then extend the circle to its diameter, which in order for the circle to be completely defined, the diameter must also be defined. So let's just say the diameter is 30. Next step on defining, similar to our rectangles, the circle must be defined to another point that is defined. And the origin is defined, so we would move it, we could define it to the origin. And we could, let's just say we want it to be 40 millimeters across from the origin, and 40 millimeters up and down from the origin. That gives us a fully defined sketch. Our next type of circle is the 3-point circle. Any 3 points will define a circle. Any 3 points that are not in a straight line will define a circle. So we can pick our 3 points. First, it gives you the option to select one, then the option to select the other, and now it will give you the option to select the third. So after you have selected your 3 points, it gives you the option for the center again, and like done in our other circle, you have to define the center and the diameter. So we can do that by defining it to the origin. Now, if you can see, we are still not done defining yet, because these 3 points are not finished being defined. The circle and the center is defined, but the 3 points used to make the circle are not. So we could just say, let that be 42 millimeters across, and let this be 50 millimeters up, and let this be 60 millimeters up. You can change around with these points based on how you want it, and this gives us a fully defined sketch. Our next circle is going to be the ellipse. Technically, the ellipse is not actually a circle, so the ellipse gives you, once again, you select a center point, and the ellipse gives you the option to go out, across, one measurement, and up and down, the other measurement. So it gives you 2 planes of measurement. 2 directions of measurement. And both of those, again, need to be defined. So we will have let's just say, the height 20, and the width or length at 8. Now, the center must also be defined. So one way we can do that is to define it to the origin, or a fixed point, and we can let that be 30 across and 10 up and down. Now, if you want your once again, this is not fully defined because the ellipse can spin around like this. So if you want your ellipse to be fully defined, you have to define the turning. One way we can define the rotation of the ellipse is by making a line go all the way through the ellipse. And for this, we can actually use the midpoint line and select the midpoint at the center. And we can, the Onshape will automatically give you the option to have it perfectly split down the middle. So I will select that, and then, again, we can use our dimension tool to select the angle of the line to the back plane. And you can make that whatever you want. You can make that 90, you can make that 75. Now that we have that defined, we'll move on to our next tool. And our next tool is the arc. First type is the 3-point arc. Basically, how this works is you select your 2 points, and then you have the option to basically select the size, or it's basically like a circle, but some of it is cut off. And here you get to select basically how much of the circle is cut off and how big the circle is. So, yeah. So you need to define the radius here, which would be, let's just say 50. And now we need to define the center. We could make the center the origin, or we can make it offset from the origin like this. But it needs to be defined to a fixed point. Now, the actual arc is defined, but the endpoints of the arc are not. So we need to define that. Once again, we can define this to the origin, and we can say we want it to be parallel to the origin. Or not parallel, sorry. We want it to be horizontal on the top plane. And we can do that for this again. We could say we want that distance, maybe this time instead of 0, we can make it 10. And that is something you can do to define the arc. Our next tool is the tangent arc. In order for the tangent arc to work, you need to have some entity for the arc to be tangent to. For simplicity, I'm just going to make a line from the origin out and define that. Then we have our arc. We would select the entity we want it to be tangent to, and then you make your arc. So if this circle was completed, it would be tangent to this line. That's the point of the tangent arc. Then you have to define this arc, and you make the radius, and you define the second point like we did in the other one. Alright, moving on. Next we have the center point arc. It's very similar to a center point circle, where you select a center point, and you select the radius, and then you basically select how much of the circle you want the arc to be. Like, you can make it half, you can make it go a quarter of the way, you can make it go almost all the way, anything you want. So I'm just gonna make it go 90 degrees. So we need to define the center. We also need to define the radius. So if you've ever wondered why we would need to define a sketch, It's because eventually when you get to extruding it, if your sketch isn't fully defined, that means that, like, it's not one sketch. Like, it could have many. Maybe it's not how you would want it to turn out. Like, if you imagined your sketch to be like this, it could be like this. It could be like that. It could be all over the place, which is why you always want to define your sketch so it's just one possible sketch. And we're going to want to define our other point too. So we just say that at 25 from the origin, and now we have a fully defined arc that does not move around. Moving on to the elliptical arc. This is also kind of like the center point arc, except for instead of a circle, it's an ellipse. So yeah, we have our length measurement and our width measurement. And then basically you get to pick how much of that ellipse you want the arc to be. So now you have to define all of the arc. So you have to define the length, you have to define the width, you have to define the center point, and you also have to define how much of this, basically how much of the arc you want it to be. So let's just say we want the point to be 10 millimeters from the origin and 20 millimeters up. And we want this point to be 30 millimeters across from the origin and 50 millimeters. Oh, sorry. This actually is fixed because if it is 30 millimeters across, there's only one measurement for that point being 30 millimeters across, because the ellipse, because there's no other part of the ellipse that is 30 millimeters across and above here. So this is fixed. Yeah. So now that we have our fixed ellipses, center point ellipse arc, we will move on to the next one. Next, we have the conic arc. For simplicity, I'll just make it horizontal. Yeah. Basically, how the conic arc works is you first select 2 points, and then you drag where you want. Like, basically, it would be like kind of like a triangle. Yeah, picture it like a triangle, but basically the line from here to the next side, it would the arc would form from the side of a triangle. So we need to define the point of the triangle, right? Let's just say we want it to be 0 from there and 100 up. Now we need to define our other 2 arc points, because right now this can move around. Say we want it to be 30 that way and 40 that way. Now we have a fully defined conic arc. Now that we're finished with the lines, the rectangles, the circles, and the arcs, we will move on to the polygons. There are 2 types of polygons. The first one is a inscribed polygon. An inscribed polygon is basically where you make a shape, and you have a circle inside. You can also pick how many sides you want your shape to have. Let's just say we want it to have 8 sides. First, we need to define the end-to-end of our polygon. So let's just say we wanted this to be 100. Oops. Yeah, we could have it as 10. We could say we want it to be 10 millimeters. Now, we need to, this polygon can still rotate around, right? So, we want to select a constraint and make it parallel. What did I do? Oops, sorry about that. So, right now there's nothing stopping the octagon from rotating around. So what we can do is we can make this side parallel to the back plane. So that way it can't rotate around. We have the measurement of the end to end, and we know how many sides it is. That makes it defined. Next, we have the circumscribed polygon. The circumscribed polygon is similar to the inscribed polygon, but instead of having the circle on the inside, the circle is on the outside. So once again, you need to pick how many sides you want and the end-to-end distance of the polygon. And once again, it can still rotate around. So we could maybe, let's just say this time we want it to be horizontal. So maybe you wanted this part to be vertical. You could just set a vertical constraint, and that side is fixed there. So now that we know the end to end, how many sides it has, the center, and that it can't rotate around, we have a defined polygon. So now that we're finished with all of our tools for part 1, we're going to do an exercise. My challenge for you guys is to make a key using the tools I showed you in this video. So, if you want now, you can pause the video and see if you can make it on your own. If not, I will go over it after. So, if you want to try it on your own, go ahead and pause the video. If not, I will show you how to make it now. Alright, so in order to make a key, we want to have basically the ring of the key, the rod of the key, and 2 little prongs. So first, we want to start with the ring of the key. Let's just say we want to have 2 circles. One circle is 40 millimeters wide, and the other one would be 80 millimeters in diameter. So now that those 2 are defined, we want to make the rod of the key. Alright, so one way we could do that is you could use the midpoint line. As shown in this video, we know that the midpoint of the line will be the first selected one, and we can select that as the origin. You could say we want it to go out to the edge of our first circle. That fully defines the line. Next, we could use lines to make the rod go down. So we know that this would be, we can put a vertical constraint on this, and another vertical constraint on, a horizontal constraint on this, and a vertical constraint on this. Now, we know that these are defined, and we can set this to however far we want. Let's just say we want it to be 200 200 millimeters far from the center of the circle or the origin. Next, we want to make our 2 prongs. For this, we could use rectangles. We could use the aligned rectangle tool to make a line out and a rectangle that comes out. We want 2 prongs, so we would do that twice. Now, both of these need to be defined, so we can make this 20 millimeters wide and 40 millimeters tall. We could do the same for the other one. 40 millimeters tall and 20 millimeters wide. Now, this one isn't quite defined yet because it can still move up and down this rod. So, we need to define this. We could either define it to the bottom or we could define it to the other one. Let's just define it to the bottom. And we could say we want that to be 40 millimeters apart. And now we're finished with our key. Yeah. Thank you for watching this video. If you found this interesting, you can feel free to check out some of our other videos. Thanks for watching.